Hello everyone, I am Rifki Ramadan. Now I want to try to explain about the paper, a review of the plantar pressure distribution effect from insole material and at different walking speeds. Actually, I have done uh, the the presentations twice on November 20 and November 27th, and I have done until conclusions, but in my last presentation, Professor asked me to explain more about statistical tests in this paper, and he asked me to find the raw data for this paper, and then I have tried to find it from the links, but I cannot find the raw data, so I cannot try to I cannot try to explain about how to do the statistical test in this paper, but I'm trying to explain more detail about the statistical test in this paper. And actually, I have explained about some of the statistical method in this paper, like MANOVA, ANOVA, and then Perti test and Pearson product moment. So in this presentation, I want to try to explain more about ANOVA, Perti test, and Pearson product moment and how to do it. So let's start with ANOVA. So this is the process how to get the result from the ANOVA test. In my last presentation, I have explained about what material we need to this research. So we in this paper we use a MATLAB to process the data that we get from the sensor, from the plantar sensor. So after we process from the MATLAB, we get some of the raw data, and then we can compute it in ANOVA test. So now I want to explain about the every single step about the ANOVA test. So ANOVA test is stand for analysis of variance. This is a statistical test used to compare means two or more group. In this paper, want to compare between the walking durations and the air insole, like I explained before about walking duration 5 minutes and 10 minutes, and then for the air insole is 140 mmHg. I forgot. And the last one is 240 mmHg. So we use ANOVA to compare the result for this parameter. So it will help to determine whether there are any statistical significant difference between the means of the group. So here are the example how to perform an ANOVA test. For the first one is formulate the hypothesis. So in here there are two types. For the we know in a statistical test there is a HO and H1. HO are null hypothesis. We assume that there are no significant difference between the group means. And meanwhile, in the H1 or alternative hypothesis, we assume that there is at least one significant difference between the group means. And then after that, we try to collect the data, gather the data from different group we want to compare. Each group should represent a different treatment or condition or category. Like I explained before, we have some conditions like walking durations and about the air insole. And then after that, try to calculate group means. After we collect the data, we try to calculate the means for each group. This represents the average value for each set of the data. And then after that, we calculate overall the means. After that, we can calculate sum of square. Calculate the sum of square within groups and the sum of square between the groups. And then we can go to the next step is degrees of the freedom. In here, we try to determine the degrees of the freedom for the between group and the within group. And then after that, we can calculate the mean square, compute the mean square between group also, and then mean square within the group, between and the within. And after that, we can try to do the F statistics. F statistic is we try to calculate the F statistic by dividing the mean square between groups by the mean square within group. And then the next step is critical value or significance level. In here, we try to determine the critical value for the F statistic based on our chosen significance level. For the example, 0.05. And then after that, we try to compare F statistical and critical value. If the calculated F statistic is greater than the critical value, we should reject the null hypothesis. It's indicating that there is at least one significant difference between the group means. And then after that, post hoc test. And actually this is the optional. And then we should know ANOVA assumes that the data is normally distributed and that the variance within each group are approximately equal. And then ANOVA doesn't tell us which specific group are different from each other. Post hoc tests are often used for that purpose. Keeping in mind that ANOVA is a complex statistical procedure and using statistical software like R and then Python, with libraries like SciPy or StatsModel, and then or dedicated statistical tools is recommended for accurate and efficient analysis. For this paper, the researcher used statistical tools like SPSS. So that's how to do ANOVA test in this research. And then after that, I want to explain about Pearty test. So Pearty test is a statistical test used to compare the means of the two related groups. This test is appropriate when the data involve pair of observations, and it aims to determine whether there is a significant difference between the means of the pair observations. So here is a simple explanation how to perform a Pearty test. So I have tried to make the flow how to do the Pearty test. So this is the step. The first one is same like ANOVA test. The first one is formulate hypothesis. We also know HO and H1, null hypothesis and alternative hypothesis. So the second one is to collect the pair data. We try to gather data where its observation in one group is paired with a corresponding observation in the other group. The pair should be related, of course. So, for the example, measurement taken before and after and interventions. And then after that, calculate the difference. For each pair, we should calculate the difference between the two observations, and then we try to calculate the mean and the standard deviations. Later on, I will explain the formula how to get the standard deviations, and after that try to calculate the standard error of the means, or SE. And also later on I will explain about the formula, and then after that calculate the t-statistics, and then the next level is degrees of the freedom. In here we try to determine the degrees of the freedom, which is equal to the number of the pair minus 1, or the formula is df equal n minus 1. And then the next step is critical value or significance level. It's try to determine the critical value for the t-statistic based on our chosen significant level, and for the example 0.05. And then we try to compare the t-statistic and critical value. If the calculated t-statistic is greater than the critical value, we will reject the null hypothesis. It will indicate a significant difference between the means of the pair observations. So there are some notes that we should keep in our mind. The first one is a pair t-test assume that the difference between pair observations are approximately normally distributed, and then it's suitable for repeated measurement on the same subject or matched pair. So, and then here are the some formula that I've explained before. The formula for the pair t-test. So this is the first one is to calculate the standard error of the means, or SE. So the formula is standard deviations divided to square of the n, whereas SD is the standard deviations of difference and n is the number of the pair. And then the second one is calculate the t-statistics. So the formula is means of difference divided by a standard error of the means. And then the last one is the degree of the freedom. This is for the determine the degrees of the freedom, which is equal to the number of pair minus 1. Now I will try to explain a simple explanation how to calculate the Pearson correlations coefficients. So actually the step is not too different from another statistical test like ANOVA test and pair t-test before. So this is the first one is we try to collect the data same like before, and then calculate the means, and then calculate the difference, and then try to square the difference. We need to square each of the difference obtained in the previous steps, and then calculate the product of difference for each pair. Multiply the difference for the two variables, and then the next step is summations. Sum up the square sum up of the square difference and the product difference, and then calculate the standard deviations. We should calculate the standard deviation for each variable, and then the next step is calculate the Pearson correlation coefficients. I will later on I will explain about the formula, and then interpret the result. So there are some notes for this test. If a positive indicates a positive correlation as one variable increase and the other tends to increase, while a negative indicates a negative correlations as one variable increase and the other is decrease. And then the Pearson correlation coefficient assume a linear relationship between a variable and its sensitive to outlier. And also same like the ANOVA, MANOVA, and PERTI test. In this test, we can do the calculations manually or use statistical software like Python with libraries, and then we can use Excel and compete with statistical tools like in this research use SPSS. So this is the formula to do the Pearson products. So the first one is calculate the Pearson correlation coefficients. So this is the formula, and the second one is the interpret the result. So this is the formula that we use to get the Pearson products. So I think that's all from my presentation. So I think that's all from me. Thank you for watching.